Section 2.2. Section 2.2 is on polynomial functions. And to start with, we're going to take a look at some problems where we need to go through and talk about the possible number of real zeros and the possible number of turning points for a polynomial. So for example number 1, our directions state the number of possible real zeros. And turning points. Then determine all the real zeros by factoring. So in order for us to do that, we need to have an equation. To start with, we're going to be looking at this function here. F of x is equal to x cubed plus 5x squared plus 4x. When you go through and talk about these different phrases that are here, we have the number of possible real zeros. What we can do by taking a look at the equation is we can predict the maximum number of possible real zeros. We may have less than that, but we will know the maximum number. And that is the same as the degree and if you remember how to determine the degree of a polynomial, it is the highest power of x. So that means for this function, x cubed plus 5x squared plus 4x, this is a degree 3 polynomial because x to the third, that's our highest degree, that's our highest exponent. This is a degree 3 polynomial, which means the number of possible real zeros is a maximum of 3. Might be less than that, but the number of possible real zeros is 3. We are also supposed to determine the number of possible turning points. And the number of possible turning points is always your degree minus 1. It's 1 smaller than the degree. So this particular polynomial is a degree 3 polynomial, so the number of possible real zeros is 3, and then we would know that the number of possible turning points would be a maximum of 2. Again, there might be less than that. Those are maximum numbers. The maximum number of possible real zeros is 3, and the maximum number of possible turning points is 2. You don't have to graph this, but just as a quick reminder, when you are taking a look at possible real zeros, these things are the same thing as the x-intercepts. And your possible turning points, those are peaks and valleys in your graph. Peaks and valleys. So when you're taking a look at a polynomial function and you're looking at the graph is going to be going upward and downward as you go from left to right. Anytime that you see your graph hit the x-axis, that is a real zero. And anytime your graph gets up to a peak, the very top point there, that's going to be a turning point. Same thing when you get to a valley, when you get to a low spot on the graph, that is also a turning point. So for this particular function, x cubed plus 5x squared plus 4x, we have 3 possible x-intercepts, or 3 possible real zeros. And again, that's a maximum number. There might be 2, there might be 1, there might be 0, but there's a maximum of 3. And the number of peaks and valleys, the maximum number of turning points is 2. In the directions, we didn't have to do any graphing. We just had to state the number of possible real zeros and the number of possible turning points. From there, though, we do need to determine all of the zeros by factoring. So I need to go through and factor this polynomial. Let me erase a little bit, and then I'll copy it down up above. So here was our function again for letter A. F of x is equal to x cubed plus 5x squared plus 4x. We're supposed to determine all of the real zeros by factoring. When you find real zeros, you substitute in 0 for y. When you're trying to find the x-intercepts, when you're trying to find those real zeros, we substitute in 0 for f of x. So one of the things I will need to do in this problem is plug in a 0 for f of x, and then go through and solve this equation by factoring. Those were what we had in the directions. So first step in factoring, factor out whatever's in common. In this problem, the only thing we have in common with all of those terms is an x. If I divide each one of those terms by an x, that leaves me with x squared plus 5x plus 4. After you factor out what's in common, then you want to go through and count how many terms you have left in the parentheses. In this case, we have 3. I know with 3 terms, we should be trying the add multiply method. So I'm looking for 2 numbers that add to give me the middle coefficient, which is a positive 5, and multiply to give me the constant term on the end times the number in front of the x squared. So 4 times 1 is 4. If I can find 2 numbers that add to be 5 and multiply to be 4, then we'll be able to do some more factoring. And there are a pair of numbers that do that. Those numbers are 1 and 4. Once you determine your pair of numbers that fit the add multiply pattern, then you can ask yourself, can I use the shortcut on this problem or not? And if you look at our trinomial inside the parentheses, we do have a 1x squared, so we will be able to use the shortcut. So our equation is going to be 0 is equal to, and we had an x out here in front, and now with our 2 numbers that we found, we're taking this x term here, this 5x, and that will tell us the variable that will go in these 2 spots. So it's going to be an x and an x, and then we have a positive 1 and a positive 4. I've now factored the right side of our equal sign. Usually when we go through and solve equations, our 0 is over on this side. You can leave it over here on the left. I'm just going to put the equal 0 over on the right side so it looks a little more familiar, and I'll erase that. 0 equals out in front. And then to finish this problem up, to find the real zeros, we simply need to do this. We're going to use the zero product property. And what that says is when you have things that are being multiplied together and they equal 0, that means one of those things that you're multiplying together has to be equal to 0. So we have 3 things being multiplied together that equal 0. That means that the first thing is equal to 0, or the second thing is equal to 0, or the third thing is equal to 0. That gives us 3 separate equations that we need to go through and solve to find our zeros. This one's already solved. The second equation, if I subtract 1 on both sides, we get x is equal to a negative 1. The last equation, if I subtract 4 on each side, I get x is equal to a negative 4. So there are 3 zeros in this problem. 0 is one of the zeros, so is negative 1, and so is negative 4. So to list these out, our book just separates these by a comma. They can be in any order. for our final answer. As a quick reminder, these are x-intercepts. Again, you don't have to graph, but just to make that connection for us, if you were to go through and graph this, there are 3 x-intercepts on this graph. One of them is at 0, one of them is at -1, and one of them is at -4. So on our graph, you end up with 3 points because there are 3 x-intercepts. We would have to plot some more points in order to figure out what this graph actually looks like, but at the beginning of this problem, they asked us to state the number of possible real zeros. We said that there was a maximum of 3, but it could be less. Then by factoring, we went through and actually found all of them, and there are 3 zeros, and what that would look like for us on a graph is that would give us our 3 x-intercepts.